Good morning to one and all. In today's lecture, we'll discuss about SISO, that is Serial In and Serial Out Shift Register. In the previous lecture, we discussed about the types of shift register and the block diagrams. Today, we will be discussing serial input and serial output shift register. Serial input and serial output, there are two types of register, right shift and left shift. Today, we will study the right shift register. So here basically we are using a 4-bit register. That means we will be using 4 flip-flop. Here the input is given as the first flip-flop and that input will be shifted. So I'll show it with the help of a block diagram. So we have seen this, we have a bit, we have 4 bit of data. So this is a most significant bit and this is a least significant bit. So we want right shifting, so our data will shift like this. Clear? So we'll see with the help of a block diagram. Here we are using 4 flip-flop. This means we have used D flip-flop. So this is your data input. This is your D3, Q3, having Q3 and Q3 bar output. Then the second flip-flop, D2, having Q2 and Q2 bar as output. Then D1, Q1 and Q1 bar as output, and D0, that is Q0 and Q0 bar output, and this is our data output. We'll see the connection. We'll connect the Q3 output with the input of the flip-flop, that is D2. Then Q2 output will be connected to the next flip-flop, that is D1, and your Q1 output will be connected to the next output, that is D0. So this is how we have connected. We have given negative clock pulse. So this is your synchronous clock pulse, and we have added a clear pin to all the flip-flop. So this is how we have done the connections. Now if we see, all the flip-flop work at the same time. So all the flip-flop will be working at the same time. Now for example, if we have been given the data that is 1100. Now see, we have been given data 1100. We are doing right shifting. This is your MSB bit and this is your LSB bit. We know that we will provide the LSB bit first to the flip-flop. So here this will be, your data input will be 0. When your data input is 0, your Q3 will be 0 and your other flip-flop will be 0 0 only. See, clear? So all the flip-flops will be 0 0. After then, when we'll provide the second data bit, that is 0. So this 0 will shift over here and remaining will remain same. After then, when we provide the next data bit, that is 1. So 1 will come over here and this 0 will get shift over here and this 0 will get shift over here and here it will remain 0. After then, when we provide next data bit, that is 1. So this 1 will come over here, this 1 will shift over here and this 0 will shift over here, this 0 will shift over here. So this is how the right shift function will perform. So we will help with the help of a block operation table. So here we will be drawing the input operation table as well as your output operation table. Input table is drawn to just feed the input of the data input to all the flip-flop. After then we'll find the output. Clear? So now see, initially we have taken 0 0 0. Initially all the flip-flops are 0. After then, when we will provide first clock pulse, when we provide first clock pulse, we give the data input as 0. So your least significant bit will be given at the input side, that is 0. So we'll get this 0 will shift at Q3. So your Q3 will be 0 and the output of Q3 will shift to Q2. So this will be 0. Your Q2 data will shift at Q1. So it will be 0. And your Q1 data will shift at Q0. So this will be 0. Then when we provide the second clock pulse, we have the data 0. So we will provide 0. Now this 0 will come over here. This 0 will be shifting over here. So your Q3 output will be shifting to Q2. Q2 output will be shifting at Q1 and Q1 output will be shifting at Q0. Now when we provide the third clock pulse, so this data, the data input will be given. So your output Q3 will be 1 only. Your Q3 data will shift get at Q2. your Q2 data will shift at Q1 and your Q1 data will shift at Q0. Similarly, when we provide the fourth clock pulse, that is 1, when we provide the data 1, so we'll get output 1 over here. This 1 will shift over here, this 0 will get shift over here, and this 0 will be shifted over here. So we can see we get the output that is 1 1 0 0. Sorry, we get the input as 1 1 0 0. So we have fed the input at the flip flop. So we get input as 1 1 0 0. Now we'll see the output operation, how output operation will perform. Here we have the clock pulse, data input, and the output of your flip flops. So initially we have seen the data input that is feed, that is 1 1 0 0. Now what we'll be doing, when we provide the fifth clock pulse, that is 0 is provided, this 0 will come over here, this 1 will get shift over here, this 1 will shift over here, this 0 will shift over here, and this data output, that is Q0, previous output, will shift at the output side. So 0 will come over here. Now when we provide the sixth clock pulse will give the data input as 0. So this 0 will come over here, this 0 will get shift over here, this 1 will shift over here, this 1 will shift over here, and we get the output as 0 only. So Q0 is 0, so we'll get output as 0 only. After then, when we provide the next bit, we see this 0 will come over here, this 0 will come over here, your 1 will come over here, and the 1 will come over here, and we get the output as 1. So Q0 पे हमें आउटपुट क्या मिल गया, 1 मिल गया, तो हमें आउटपुट 1 मिल गया. जब हमने सेवेंथ क्लॉक पल्स इनपुट दिया तो हमारा डेटा इनपुट हमने क्या दिया है, 0 दिया है, तो 0 क्या हो जाएगा, यहाँ पे आ जाएगा Q3 पे. Q3 का जो डेटा है प्रीवियस वो शिफ्ट हो जाएगा Q2 पे, तो वो 0 है. फिर Q2 का जो डेटा है वो शिफ्ट हो जाएगा Q1 पे, दैट इज 0, एंड आफ्टर देन your Q1 data will shift at Q0, that is 1. Your Q0 is 1, we'll get the output as 1. Now see, here we got the output that is 0 0 1 1. We gave the input data bit that is 1 1 0 0, and we get the output as 1 1 0 0. Same. Now here see one more thing. Here we were applying 4 clock pulses for the input. We applied 1 2 3 4 input. 4 clock pulses were provided at the input operation, and at the output operation we only applied 3 clock pulses. So for the output operation only 3 clock pulses will be applied. So by this we can see that the total clock pulse will be 7. So total clock pulse is 7 for your 4 bit of data. That means कि for 4 bit of data we are using 7 clock pulse. So we can calculate it with the help of a formula. We have been given your n-bit SISO, that is serial input and serial output. So if we say that 2 to the power n minus 1, that means your total clock required for both input and output operation. Means कि हमने क्या देखा कि 2 to the power n minus 1 से हम कैलकुलेट कर सकते हैं कि हमें कितनी क्लॉक पल्स रिक्वायर्ड है एट द इनपुट एंड द आउटपुट ऑपरेशन. फॉर एग्जाम्पल अगर हम इसी की बात करें, हमारे पास क्या डेटा था, 4 बिट डेटा था. 4 बिट डेटा मीन्स 2 to the power n minus 1. 2 to the power n minus 1 means 2 to the power 2 into 4 minus 1, that is equals to your 7. तो हमने कितनी क्लॉक पल्स यूज़ की, 7 ही यूज़ की. ना अगेन इफ़ आई टॉक अबाउट 5 बिट, अगर मैं 5 बिट डेटा लूँ तो क्या होता है मेरा फॉर्मूला 2 to the power n minus 1, तो 2 into 5 minus 1, सॉरी अगर मैं अपना डेटा बिट 8 बिट लूँ, if I take 8 bit of data to 2 to the power 8 minus 1, so this will be equals to your 15. That means कि we will be applying 15 clock pulse. Clear? So what we did in serial input and serial output, today we saw the shift register, that is your right shift register. We have seen in right shift register we'll consider the data lowest significant bit and that data will be provided as an input. तो जो भी हमें डेटा दिया होगा लीस्ट सिग्निफिकेंट बिट होगी, उस डेटा को हम प्रोवाइड करेंगे एट द डेटा इनपुट, और क्या हो जाएगा उसकी राइट शिफ्टिंग होती रहेगी और हमें क्या मिलेगा, डेटा आउटपुट मिलेगा. व्हाट वी डिड, हमने ऑपरेशन टेबल में क्या देखा, 2 ऑपरेशन टेबल बनाई हमने. प्रीवियसली हमने जो डेटा दिया उसको हमने स्टोर किया अपने फ्लिप फ्लॉप पे. उसको स्टोर करने के बाद हमने क्या निकाला, उसका आउटपुट निकाला. तो हमने क्या किया, जो भी हम इनिशियली देंगे हमारे डेटा को वो एज इट इज़ Q3 पे आ जाएगा, जो इनपुट डेटा होगा। उसके बाद जो मेरा प्रीवियस डेटा होगा वो शिफ्ट हो के Q2 पे आ जाएगा। फिर जो Q2 का डेटा होगा वो शिफ्ट होके Q1 पे आएगा, और जो Q1 का डेटा है वो शिफ्ट होके Q0 पे आएगा। तो सिमिलरली वी विल बी परफॉर्मिंग द ऑपरेशंस फॉर योर रेस्ट ऑफ द क्लॉक पल्स। तो सारी क्लॉक पल्स पे हमने ये ऑपरेशन परफॉर्म करेंगे और वी कैन गेट द आउटपुट दैट इज 0011. So this was all about your serial input and serial output shift register, that is right shift register. In tomorrow's lecture we'll discuss about your left shift register. Thank you.